I have this image of the calculator. However, I bring a virtual calculator. I want to show you in your moment. No, no. So let me recall again the complementary property that we studied last class of the logarithmic functions. So the first one is logarithm of the any base of 1 is always 0, regardless the base. See, the base is 10, is the, remember, two standard logarithms that we have. Default when you don't specification the number here of the base, you suppose default is 10, is 0, or natural is also 0. I want to illustrate in the calculator now. And number 2, when you have the same number in the base and same number in the arguments of the function, the answer is 1. So log of 10 is 1. ln of e is also 1. Remember, the base of the natural logarithm is e, okay, it's the famous irrational number. And when you put together, the exponential logarithm, suppose you have a base a, and you put logarithm base a of any number, the answer is any number. So, for example, so suppose you have base 10, log of 3 is equal to 3, or e ln of 3 or 4, another number, f4. It's like this function undoes each other, no? So this cancel out, mentally, no? No, in the paper is no good. Actually, it's not cancel out. It's inverse function. Okay, and number 4. Number 4 is similar, but you put a logarithm first. Doesn't matter the order. An exponential is equal to x. So in other words, you put log of 10 to the 5th power, 5, or ln e to the 10th power, 10. Let's practice, bro. Let's practice using the calculator. Okay, let me know if you see my visual calculator. Let me try to share. Okay. Do you see my visual calculator? Do you see my visual?
Yes.
Okay. And you see only the visual. Okay. I understand. And you see whiteboard also or no? Only the visual?
Only the calculator.
Only the calculator. Okay. Okay. So in my screen, no, in my screen I see both, but no problem. I'm using this idea because I want to verify the thing we discussed before. Suppose logarithm. Okay, there you go. We have logarithm of, look, we have 2 logarithms here in the calculator. Any calculator we have in the calculator you have, do you see the key log and the key lm? Do you see in your own calculator?
Yes.
Entonces I encourage you, let's do it simultaneously. log of 1. I type in 1. 1. You see que 0? And
Yes.
ln of 1 again is 0. So basically, any logarithm, regardless where the base, the answer is always 1. It's a property number 1, P1, complementary property. Let's move on to the property number 2. When you have, for example, logarithm of, and you put 10. In this case, there are perfect coincidence between the base, que default is 10, and the argument que I passing through the parentheses of the function, entonces the answer is 1. Likewise, lm of E is in the keyboard is also 1. It's a property number 2. Super. Now, property number 3, you have exponential. For example, you have 10, base 10. We are working with and the calculator always is standard, 10 and E. Then you put a power. You put a power, but you put now in the power, you put logarithmic log, the same base of 3. The answer is 3. Okay, now using E, exponential power, Lm of 4, and the example I did in the board was 4, and the answer is 4. Okay, one more thing. Now I put together, pero in different order. So it's a logarithm first, and exponential secondly. Where's the base? The base is 10, no? Power 5. Oh, the answer is 5. Now it's doing natural logarithm of what? Of the E power 10. And the answer is 10. So far, everyone follow me? You did in your own calculator?
Yes.
Excellent. Now let's move on again to the whiteboard, because I want to discuss in detail now the change of base formula. Get the property number 8. So we have property 5, 6, and 7, but I want to discuss it after. I want to take advantage of the calculator now. So the property 5, 6, and 7, we discuss it after. We focus now on property 8. Property 8 say, do you see my whiteboard? Or no?
Yes.
Okay, cool. So property number 8 say, let me try to understand the formula and after the application of the formula. Suppose logarithmic of any arbitrary base, I call A, of the one specific number. Suppose that the base A is non-standard. It's the regular case. And you convert to another base. In this case, I call B. I suppose that B is standard of the same number divided by logarithm of the B, que es standard of the base, the old base que es A. This is the formula. O sea, this is the non-standard. And B is standard. Not necessary, you know, to be standard. It's arbitrary base que you make a decision according to the problem. But the most frequently scenario is que B is standard. Okay, so let's practice. I bring 2 examples and we are doing this example we are doing by hand, but I want to verification with the calculator. So we have 2 options, guys. Some example we can do by hand using intuitive idea, que basically is conversion to exponential. Let me explain. For example, logarithm base 3, non-standard of 81. You need to find that. You put the x, you don't know. You convert to exponential. And the conversion to exponential, the base is obvious 3. You put the big 3. This is small 3. Now it's big. The exponent is thinking I want to find equal 81. But 81 is 3 to the 4 power, because 81 is not 3 times 3 times 3 times 3, 4 times. Therefore, the conclusion is x equals 4. not always happen this situation. Maybe another problem we see after that, the exponent is irrational number because the bases, there are no coincidence. Okay, pero suppose que now we're doing bajar, no problema, but I want to apply this formula. By the way, the name of this formula is change of base formula. Okay, cool. So now I need to come back to the problem. Base 3 of 81 is equal to, say you put a fraction and you make a decision, for example, to use a standard, and the standard is log 81 divided by log of 3, que es A, no? Que es the whole base. And in this case, I'm using como logarithm base 10, but why not? We can using natural. Okay, this is two standard logarithmic. Remember the log is using in science, chemistry, physics. Ln is using in calculus, in mathematics, but in calculus. The reason is not obvious now. In your moment, you can see why. But okay, going back again to the calculator and let's doing this computation in the calculator. Okay, let me try. Calculator. Do you see? I suppose que no. The calculator, let me see, calculator here. Scientific calculator, virtual. So do you see my calculator now? Do you see?
Yes.
Okay, let me clear all things. I want to write, let me put a background, the whiteboard, to see, to understand exactly what are you doing. You continue to see the calculator, no?
Yes.
Okay, you put log 81 divided by, outside the parentheses, of course, divided by division, log again of 3. Look at the answer, 4. Do you see? Do you see? Okay, so far from today, when I ask you what is the logarithm of something, and you see you don't know, you have no justification. By hand, using intuitive idea, pero this is when it's possible. The majority of the scenario is impossible, and you using calculator. And likewise, suppose I make a decision LM. I don't know why. 81. Outside the parentheses, divided by ln of 3. So you get the same answer. Regardless what base you're using, okay, you obtain the same answer. Fantastic.
Yes.
Okay, so let's practice now. Why not? Quickly, not too complicated. Let's practice now. Let me come back again to the whiteboard. Do you see whiteboard?
Yes.
Okay, let me delete everything. Erase the whiteboard. Let's practice the problem of property 5, 6, and 7. Extremely important, guys. 5, 6, and 7. Because this allows us to manipulate the complicated expression using logarithmic and exponential. The property if I say logarithm of the multiplication two expression, okay, I want to call m and m, you separate into logarithm with the addition. Okay, now when this division is subtraction, that the positive guy is the positive the expression in the top, and the negative guy is the expression in the bottom. And property 7, in my opinion, is the most important because it's magic. When you have m to the r power, the r represents the exponent fly outside. Okay, is equal r times ln of m. And this property is amazing because this allows us convert exponential equation to linear equation because the exponent go magically to the front like a factor. Okay, let's practice. Let's practice easy example and the test I put 1 or 2, but elementary, no big deal. Suppose you have logarithm example 1 of the property 5, 6, and 7. Logarithm base 3 of m plus logarithm base 3 of m, and the question say express as a single logarithm. You have several, 1, 2, 3, 4, 5, and you condensing in only one. Entonces, yes plus, entonces logarithm base 3 of m times m. And this is extremely important. This is possible when the base is the same. If the base is different, no. The property no apply when the base is different. Only apply when the base is the same. Entonces si the base is different, what should I do? You are in big trouble because it's very, very complicated. I promise you see example of this. Pero no now. Example 2 is 4 times logarithm base 2 of x. I combine number and variable, I don't know, minus logarithm base 2 of y, and you condensing. Entonces, in this case, I see que es minus. Si es minus, es division. And also, I see a factor 4 in the front, and this fly, because the action is totally inversed, is exponent. So you condense in only one logarithm base 2 of x to the 4 power and y. And this is the argument. I recommend okay, the argument and any expression. Some people write like that. Some people write logarithm 2. This is correct. But much better, in my opinion, is open parenthesis. Because this is synonym to the function notation, okay, it's fn2, no? Nobody write like that, fn2. Because I don't understand what it means that too. And to say this indicates the argument. I don't know, the practice to do fast, some people omit, but I don't like. I try to put the parenthesis always. Okay, do you understand the example 2 in which you apply, in this case you apply only property 5. However, in this case I apply property 6 and property 7 together. Yes or no?
Yes.
Okay, one more in this direction. Is 3 times logarithm base 6 of x plus 5 logarithm base 6 again, but the variable is x minus 6. And the same idea, no? You condensing. Condensing means that you have 1, 2, 3, 4, 5 logarithms, and you write like only one. Only one logarithm, okay? Logarithm base 6. And the factors, okay, 3 and 5, you put like exponent. Exponent of what? Exponent x to the, well, in this case, no fraction, because it's no negative. So it's x to the third power. And x minus 6 to the fifth power. And you put a bracket here to indicate the argument of the logarithm. Cool? One more, the last one. Suppose I put 1/2 logarithm base 3 x minus 4 minus logarithm base 3 of x, and you need to condense it in only one. Well, this is a factor, but the factor is 1/2. Well, you can write, this is subtraction, so you put logarithm base 3 of the fraction, and the top you put x minus 4 raised to the 1/2 power, and the bottom you put x. Okay, this is one possibility. Another possibility, okay, you need to be alert, because in calculus you're using is now conversion, fraction exponent to radical notation. Entonces, this is equivalent to say square root x minus 4, que es equivalent to say raised to the 1/2 divided by x. Something like that. Cool? Do you follow me? Do you understand very well or no?
Yeah.
Okay, now let's do in backward. Suppose I have only one single logarithm, and you express it, you expand completely different in several, and express the fact and express the power as a factor. Okay, let's do it. Suppose example, this is completely different. Completely different. Suppose you have example 1, expand, no condensing. You have logarithm 17, base 17 of 8 over 19. Oh, es division. Si es division, es subtraction. Entonces, you separate logarithm base 17 of a is in the top, minus logarithm base 17 of 19. Well, in this case, you can compute it if you want by calculator, but no, this is not the goal now. This is not our goal. Example 2. Suppose that we have logarithm base 5 of x to the 5th power divided by y to the 6th power. And you expand. Division, subtraction. Entonces, es logarithm base 5 of x, but this power 5 go to the front like it's factors, minus 5, positive 5. Minus logarithm base 5 of y, and this exponent 6 go to the front as a factor. Cool? One more big example. Suppose natural logarithm of one expression, complicated, is m to the 5th, m to the 8, x to the 6, and y to the 7. You expand. How many logarithms we have in this? We have 4, no? Each for one expression, 1, 2, 3, 4. And you copy ln of m positive because in the top, and 5 is exponent, go to the front as a factor, plus 8 ln of m, also positive because in the top. Everything in the bottom is negative, so it's minus 6 ln of x minus 7 ln of y. Final answer. Super clear?
Yes.
Okay. So we are ready in this moment to start doing exponential equation, but complicated. Remember the scenario in which it's impossible to express both sides using the same base or the common base. You remember, for example, the classical 2x equal 4. Oh, pretty easy. And 2x equal 3 is super complicated, right? Because this is easy, because I know the 4 is 2 to the second, therefore x is equal to. Don't. This is the easy way, using common base. However, it's impossible doing this example in this direction. Okay, no problem. Now, the reason is that in this case, you don't find integer or rational solution. You get irrational solution. The majority of the logarithm give me irrational number. And you identify as irrational because the decimal is real, but it's decimal, but infinity non-repeated decimal places. Okay, so what is the traditional way? Well, okay, I cannot solve it, but you apply logarithm. What kind of logarithm? Standard. Standard because you ending in the calculator. So if you apply logarithm, what logarithm? The logarithm you prefer. Common or natural. The answer doesn't change. You apply logarithm both sides. In this case, I select common logarithm, base 10. And you apply in this moment property 7. And the property 7 say that this exponent go to the front as a factor. X time logarithm of 2 is equal to logarithm of 3. And magically, you convert this original exponential equation in one linear equation because logarithm of 2 is a number and logarithm of 3 is another number. We are number, of course, but it's number. So in order to isolate the x, you divide it by logarithm of 2. Cool. And this is the, so you put in the calculator. Well, no, depende of the calculator. This is the exact answer. But in this problem, in the test, I ask you no exact answer. I need approximate answer. Yeah, I always specification because it's infinity decimal place. One number, suppose the most typical is 4 decimal place, and you round or truncate, depending on round the solution. Let's do it. It's logarithm of 3 divided by logarithm of 2. Let me use my virtual calculator and you try to compare my answer with your answer in your own calculator. Okay, exactly where there you go. There you go. Okay, let me try to share again. Okay, calculator. Okay. You see the calculator?
Yes.
What's going on? Okay. Okay, let me erase clear on the calculator. Just I put log of 3 divided by outside the valence, of course, divided by logarithm of 2. Boom. And this is the answer, 1.5849. And suppose I want to write the answer using the 4 decimal place. Let me write it's 1.5849. Depending if you truncate or you round off. Okay, in this scenario, the next digit after the 9 is 6. This is 6 to say it's 50. It's 1.5850. This is round off 4 decimal place. And this is truncate 4 decimal place. Okay. Do you understand very well or no?
Yes.
Okay. So we ending. Let's doing something because it's for me it's not countable. Go to the calculator. Go to the whiteboard. Go to the calculator. Go to the whiteboard. Now I want to do the equation that we're doing now and my own in the algebra and the whiteboard, and you help me the approximate answer. Okay. So I'm doing the algebra and you help me with the calculator, your own calculator. Okay. Example 2. The reason I cannot solve it using common base is because the answer is irrational. See, the answer is irrational. Irrational have infinity decimal place non-repeated. Therefore, okay, 2x equal 8. Suppose this equation is 8. There are many ways. Anyway. So you see definitely, well, A, I can express in using common base like a 2. But what I am doing with this 5? No, I don't know. Definitely no. Okay, so you isolate the exponential part. So you divide it by 5 both sides. We have 2 to the 3x equal a over 5. So now the only possibility we have is apply logarithm. What kind? I want to practice with the LM. Standard o LOG o LM. It's the same. Sense. Let's apply LA. LN to the 3x equal LN a over 5. And apply one more time the property 7 to allow us this exponent go to the front, like a 3x. Logarithm of 2 equal ln a over 5. Okay, so my goal is solve for x divided both sides by 3 ln 2. You know how magically the exponential equation become like a linear equation. Science fiction. X alone is equal ln a over 5 divided by 3 times ln of 2. So be careful, be careful. My recommendation always is. My recommendation is always is. You try in order to put in the calculator. You can put like that, no problem. It works perfectly. However, I recommend express it like only one, no two, no coefficient. No. You write like that. A over 5. This is stay the same, but this no. You put logarithm of, and this exponent fly like exponent is 8. And put in the calculator like that. It's easy, in my opinion. One logarithm on the top and only one logarithm in the bottom. Never two, never coefficients. You condense it in this idea. Put it this and give me 4 decimal places. Okay, let me try in my own calculator, but the calculator I have in my hand, no virtual. Okay, I put natural logarithm. You need to be familiar, guys, with the key for the natural and log. A over 5, the A divided by 5. Close the parentheses, extremely important. The parentheses can close the argument of the logarithm of the top logarithm divided by ln again of 8. Okay, and now I want no exact answer, I want approximation. Approximation using 4 decimal place is, who help me? You did that? Come on. Opinion. Opinion. Brianna, Edward, Jenny, Kylie, Gladys. 0.222, exactly. Jenny say, okay, Edward, is super good. Guys, you know or you don't know? You get this answer? 0.2260. Okay, because the next teach is 2, 4 or something. Bang, final answer. Any questions so far? Gladys. Good. Okay, super. We are the best. And I want to put up one more complicated problem. Example number 3, no? Yeah. Example number 3 say 0.3 is the base. Wow, crazy. 1 plus x is the exponent. Equal 1.7 is the base. 2x minus 1. Okay, I want to explain in detail, step by step, and what is the idea in the calculator. Because obviously, this is complicated exponential equation, and you expect irrational solutions. Okay, you apply one more time. Either logarithm natural, or we have two options, guys. Natural is LM. Common is LOG. What do you recommend me? Natural or common? Come on. Opinion. Doesn't matter. The answer. Natural, okay. Jenny say natural, okay. I did in my paper, Jenny, use a natural. Okay, natural then. ln of 0.3 raised to the 1 plus x is equal ln 1.7 raised to the 2x minus 1. The only thing I did, guys, was apply logarithm of both sides. Okay, no problema, because I know que logaritmo es a one-to-one function, ¿no? Entonces, one value of the x give me one value of the y. But one more time, you apply the famous property number 7. Okay, the famous property number 7 allow us this exponent 1 plus x and this exponent 2x minus 1 go to the front like that. 1 plus x, of course, parentheses, because you consider 1 plus x like a one binomial, one package, logarithm of 0.3. And don't forget this parenthesis to indicate that this is the argument of the logarithmic function equal 2x minus 1 ln of 1.7. So far, everyone follow me?
Yes.
Entonces, in that moment, definitely we have a linear equation. Somewhere, logarithm of 0.3, but it's a number. It's a number. Entonces, you apply the algebra, que you very well know. You apply this distributive property in order to remove the parenthesis. It says 1 time logarithm of 0.3 plus x time logarithm, pero ln we are using, no log. ln of 0.3. Okay, the operation in between this is time, pero I suppose default, not necessarily, right? Symbol. So now distribute the property again here and here is 2x ln of 1.7 minus ln 1.7. Okay. See, my goal is solve for x. I try to move any term can contain x to the one side, same side. For example, there are many ways to solve this. This stay here because I like so much because it's positive. This is also positive, but it's okay. I move to the other side, pero negative x ln 0.3. Entonces now ln 0.3 just bring down plus ln 1.7. The action I did was I moving this guy to the left. Like that. I'm moving this to the right. Is this. Of course, with the opposite side. Now be ready almost to, you rewrite now, ln 0.3 plus ln 1.7 is equal, and you factor out x, because I think I want to solve for x. You have 2 times ln 1.7 minus ln 0.3. Okay, so x alone, you divide both sides. You divide both sides by 2 ln 1.7 minus ln 0.3. Because my goal was solve for x. So they say goodbye, cancel out, and we have x alone equal this. Ahora now, I put in a calculator like that. You can, of course you can, but no, it's a little bit crazy. Much better. Remember, my recommendation is you do something completely backward, condensing, and only one single logarithm. So now I can see clear in the top part you apply the property number 5. And the property number 5 say that you have two logarithms, and when you condense it in only one, you are doing the multiplication, and the multiplication is 0.3 times 1.7. Okay, it's 0.51. Oh, nice. I like that. Because this is, maybe it's complicated, the parentheses you need to open in the calculator to differentiate the top part and the bottom part. And the bottom part, you apply the property number 6 because it's minus, but you apply the property number 7 also because we have a factor here. Actually, we have logarithm of 1.7 squared is 2 divided by 0.3. Okay, so I put in my calculator before 1.7 squared divided by 0.3. 1.7 square division 0.3. The answer is 9 point. So the answer of this was 9.63 repeated. 3. Actually, the thing I tried to put in my calculator was ln of 0.51 divided by ln of 9.63 repeat. Or you put it something like that. Okay, now round to decimal place. 3, okay, 4 decimal place. Round to the 4 decimal place. 4. No 3, 4 decimal place. I need help for this job. Nobody can do that? Acuérdate, negative, yeah, negative 0.29, 33 or 35. 0.2975 or 73. In my paper, I have 5. Okay, let me try. Let me try one more time. In my own calculator I have in my hand is natural logarithm of 0.51 divided by, so now I put much better logarithm of natural logarithm of, entonces no 9.63333 es, I put 1.7 square, 1.7 power 2 divided by 0.3, 0.3, and close the parentheses and press enter. Yeah, you're right. It's 73. It's 73. I don't know why I put 5. It's 73. Very, very well. Yes. Let me fix it in my paper. 73, no 75. 73. Okay. Any questions so far? No? Too long? Sorry. But this is no big deal. You apply the procedure. Okay, see, I summarize, recap, apply logarithm both sides, apply property 7. Property 7 magically convert the exponential equation in linear equation. You apply distribute the property classical of the algebra. You solve for x using the rule that frequently we are using to solution linear equation. And the last moment is before putting the calculator, you condensing several logarithms at the top, 2 or 3 and only one, and directly put in the calculator. Okay? Any question? You need to practice. And the practice is using Alex, the homework in Alex, right? Let's see example 4. Example 4. Example 4 is a little bit different. It's another exponential equation, but a little bit, tricky. It's 4 to the x minus 10 times 4 to the minus x equal 3. And this is classical. In YouTube, there are a lot of examples of the exponential. Another is very, very sophisticated, no? You need to apply different rule. But in this case, no. In this case, it's easy. Because immediately you need to know, can you avoid negative exponent? Negative exponent, no good. Negative exponent, no good. Because now, if you want to eliminate this, you multiply the entire equation by 4 to the x. Because I know when you multiply 4 to the x times 4 to the x is 4 to the x squared minus 10, and when you multiply 4 to the x times 4 to the minus x is 1, because it's 4 to the minus x times 4 to the x is equal to 4 to the 0, and 4 to the 0 is 1. O sea, it's just 10. Equal, and this time this is 3 times 4 to the x. Wow. And this equation look like similar to the equation that we studied before, case quadratic in front. How do you know that? Because we have one expression, square, power 2, and the same expression, power 1. If you declarate, remember this is a kind of equation that you apply, you solve it by substitution, use substitution. 4 to the x is u. So you have u squared minus 10 equal 3u. Wow, easy. U squared minus 3u minus 10 equal to 0. I put in standard, ready to solving using factorization or quadratic formula. In this case, I suppose que factorization is easy because the combination is 5 and 2, no? 5 times 2 is 10, and 5 minus 2 is 3. It's obvious that this is negative and this is positive. One solution is 5, another solution is minus 2. But this is the final answer. No. This is a u value, but I need x values. And my problem at the beginning says solve for x. Okay, so now I have two solutions the u. I need to convert into solution of the x. Suppose u equal 5 and u equal negative 2. But who is u? You remember was 4 to the x. Basically, I have 4 raised to the x equal 5. Oh, I have one exponential equation, and this exponential equation, the only possibility for solving is using logarithmic, because 5 and 4 never we can express it using common base. No, never. And another is 4 to the x equal minus 2. Oh, maybe this is possible, but I don't know. Entonces yo apply logaritmo both sides. You apply log. Why not? Log. Because we discriminate log, we are doing everything using ln, but the answer doesn't change for the logarithm you select. You apply one more time the property 7. This exponent goes to the front, x log of 4, log of 5, divided by log of 4 both sides. X alone is log of 5 divided by log of 4. This is the exact answer, but whenever I want in the real life engineer or science, I need approximation because I have no idea what it looks like that. So now you put in a calculator, please, and round to the 4 decimal place. Who help me? $1.1610. Yeah. Everyone is agree or disagree with this answer? Yeah. 1.1610, no? See, because actually is 9 something, no? Let me try. It's ln of 5, or naturally, either way, of 5 divided by ln of 4. In decimal, I want. Yeah, because actually the answer for the calculator is 1.16096. At least my calculator, no, this depending the decimal approximation that you default bring the calculator, or there are another calculator que allow to adjust. However, I need 4. 1, 2, 3, and 4. This is 6 is greater than or equal 5. Therefore, you're increasing 9 plus 1 is 10. Perfect. This is the solution. 1.1610. Now let's move on to the second solution. 4 to the x equal minus 2. Sound weird. Because, okay, suppose. Yeah, I remember something about exponential functions. I remember that the exponential function look like that. The exponential function, we have asymptote here at y equals 0 horizontal asymptote. An exponential function never is negative. And negative 2, I suppose que es negative 1, negative 2, like that. So this line, que es horizontal line, y equals negative 2, never is equal to the exponential function 4 to the x. Because they are not intersecting. So you know that, you understand that we have no solution. Suppose que you don't know. No problem. Another possibility is, well, no, let's solving exactly the same we are doing here. You apply logarithm on both sides. Natural, log, either way. You apply the property number 7 one more time. This x go to the front. Oh, entonces I see some weird. Que logarithm of negative number, que es impossible, no? Suppose que you remember that, no? Because the domain of the logarithm function is only positive, no zero, zero no, is asymptotically, never touch zero, and positive. Never is completely undefined. Okay, this is another moment you say, oh, no solution. But suppose that you don't know that, or you don't remember that, and you try, and you divide both sides by logarithm of 4. So you have logarithm of negative 2 divided by logarithm of 4. I'm putting the calculator this and let me know where the matches you see on the displays. So logarithm of negative 2, ln negative 2 divided by ln of 4. Where's the matches you see? At least in my calculator, I see these matches. Error. Okay, error. There's a Jenny. Jenny said this is error, and the Jenny calculator is error. And my calculator say domain error. Let me see another calculator. Edward say error again. Okay, definitely that part do not afford any solution. Therefore, the only solution that we have in this problem is this. Cool. Okay, we bring another easy, similar. I have another more, que like for you, extra credit. Pay attention. Pay attention. Pay attention. Let me erase the board. This is relatively easy, but the same, you know, category of the thing we ending in quadratic in front. No, and you use to do. Suppose 1 to the x plus 2 to the x is equal to 4 to the x. But I need a little bit help. What should I do? What should I do? And the question says, so for example, come on, help me with the chat. Oh, activate the microphone, say something. 2 power x plus 2 power x equal 4 power x. Solve this equation. Wow, it's crazy. No. En decimal approximation. En decimal approximation. Okay, you have idea or no? We take advantage a little bit the same idea que the common base. ¿No? because I know that 4 is 2 to the second, and 2 is 2 to the 1. And also, why? 1 to the x. 1 is a magic number. When you raise to the any power of 1, so there are no reason. This is just 1 to write x here. No. Plus 2 to the x is equal to square to the x. Yes or no? And one more time, you have 1 plus 2 to the x is equal, multiplication of the exponent is 2 to the 2x. Entonces you have quadratic in front. How do you know? Because we have one expression. And you have another expression. Square. It's an exponent 2, no? Because you put the x here, and the 2 here is the same, no? 2x. And you declare u substitution 2 to the x. Always the smaller exponent. So 1 plus u equal u squared. Wow, easy. Quadratic equation. Let me write the quadratic equation in standard. U squared minus u minus 1 equal to 0. I move everything to the right. Yeah, interchange left and right. By factorization, it's impossible because the solution is irrational, but it's real. But you apply the quadratic formula. A is 1, B is negative 1, and C is negative 1. It's minus B plus and minus square root B squared minus 4AC divided by 2. Quadratic formula es the only possibility. Entonces, 1 positive, doble negative, plus and minus, square root 1, negative 1 square, que es positive 1, minus 4 multiplication by 1, multiplication by negative, divided by 2 times 1. The operation inside is 1. Be careful with the sign. We have 2 minus, double minus become positive 4, because 4 times 1 is 4 times 1 is 4, no? But negative, double negative become positive is 5. And when you find the square root of 5, the square root of 5 is irrational number. And I leave it like that if you want to express exact solution. Entonces, 1 plus or minus radical 5 divided by 2. So we have two u value, real, totally irrational. And you put in the paper, u equal 1 plus radical 5 over 2, and u equal 1 minus radical 5 over 2. Okay, and who is u? U is 2x. The 2x is equal 1 plus radical 5 over 2. And you apply logarithm. What kind? Either way, natural maybe. We apply one more time property 7, and this x go to the front. That's a factor. Okay, finally, divided by natural logarithm of 2, both sides. And this is a moment, this is the time to put in the calculator. There you go. Wait a second. There you go. The answer is, in my calculator, you let me know if I'm right or wrong. x equal 0 point 6946942. Uh-huh. And you get this answer or no? Let me know. And the answer for this was yes or no? And they're right or wrong? Let me copy that. I never solved this. 1 plus radical 5 over 2 divided by ln 2. The approximation is 0.6942. And what about the second part? Well, the second part is possible, is no solution. It's obvious, right? Why? Because radical 5 is 2 point something. Radical 4 is 2. Radical 5 is 2 point something. 1 minus 2 point something is negative. Entonces, when it's negative, exponential never is negative, entonces no solution. By the same reason we see in the last example. Cool? Everyone follow me?
Yes.
Ok, entonces de extra credit. It's easy. And don't worry, you have time. You turn into me in the same time. Can you send me the test 3 on paper? You have 25 questions, no? You have now 26 if you take this. Okay? Yeah, I grade that. You put extra credit, I understand. This is 6 to the x plus 4 to the x is equal to 9 to the x. Solve for x. This equation. Using your imagination and your common sense. Okay, cool. No, if you want to participate, it's 5 point extra, 5 point. Like one extra question. You don't want, but okay, no problem, I understand. Of course, you express the final answer in decimal approximation. Decimal approximation, you see, we're using that symbol, because indicate approximate. The symbol is equal. Exact answer, the symbol is approximate answer. Any question? No problema. Erase the board. Now I want to discuss another kind of equation. Solving the logarithmic equation. This equation can somehow involve logarithmic function. So when you see log or ln or not necessarily standard base, arbitrary base, crazy base, it's logarithmic function. So I want to explain the strategy to solve this logarithmic case a little bit different to exponential. So far we studied two kinds of exponential. The classical easy, in which you're solving using the common base, nice. Another complicated case impossible doing this way because the solution is irrational numbers and you apply logarithm on both sides. Now we have equations that contain logarithm. Example 1, for example, here, first one. Logarithm base 3, oh, no standard, okay, no problem. Of x plus logarithm base 3 x minus 24 equal 4. This is a classical logarithmic equation. Okay, entonces step number 1. is you have 2 logarithms, 3 logarithms, 5 logarithms, 20 logarithms, you condense it in only one. So you apply the property number 5 in that case, and you copy only one log base 3 of the multiplication this times this. This is m, and this is m. So it's x times x minus 24. And everything is inside the argument of the function logarithm. There is a reason I enclose in the parenthesis or bracket, either way. 4. Everyone follow me so far? Yes or no?
Yes.
Okay. This is the first step. Step 1. Step 2 is to see much better. You convert to exponential statement. And the way to indicate for me in the test, you put an arrow and you put 2 exponential. I understand exactly you say. Okay, remember the conversion. This is extremely important. The conversion to exponential is what's the base? And this is logarithmic statement. What is the base? What number is the base?
3.
3. So this is small 3. I don't see. Near I see. Now you put big one. And what is the exponent? You write 3 to the something. What is the exponent?
4.
4 is the exponent. So therefore, is this 4. Is equal the expression inside the argument is x minus 24. Okay, important. In this crucial moment, this new equation is no logarithmic equation and it's no exponential equation because 3 to the 4 power is 81, and you why not apply this 3 with the property here, x squared minus 24x. Wow, it's a quadratic equation. So basically it's x squared minus 24x minus 81 equal to 0. And you put in a standard, that's all we happen to solving that. Okay. This is the thing I want you understand. You are doing transformation. You condensing several logarithms only one. You convert to exponential form. I don't know why magically I have in my hand now quadratic equation. But the thing you need to understand, okay, because logarithmic function is picky, very, very picky, and do not accept negative number inside the argument. Therefore, the solutions of this quadratic equation, you need to verify always mandatory into the original. It's similar to the thing we study in radical equation. Sometimes happen we get extraneous solution, and the reason is clear because we are doing the manipulation of the function que es picky, que we have restriction in the domain. Entonces the positive solution is okay, but the negative solution is not okay. Okay? Now, okay, I suppose que in this case it's relatively easy by factorization. You see the combination or no? 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 Okay, no problem. Si you don't see the combination, remember, actually, the best way is apply the quadratic formula, no? A1 is negative 24 and C is negative 81. And you apply the formula minus B plus or minus square root B squared minus 4AC divided by 2A. In our specific example is 24 positive, double negative, plus or minus square root negative 24 squared become positive, I suppose, minus 4 multiplication by 1 que es A, multiplication by minus 81 que es C, but the whole thing by 2 times 1. Okay, and we focus 100% to the computation, the expression inside the radical. And 24 squared, let me try. 24 square. 24 square is 576. Oh, be careful, double minus, become positive. And 81 times 4 is 324. And 324 plus 576 is 900. And square root this guy is 30. Oh, I like that. It's easier. Basically, we have 24 plus or minus 30 divided by 2. Okay, that's all we are doing. We separate into solutions. 24 plus 30 divided by 2. And 24 minus 30 divided by 2. Well, this is 54. Divided by 2 is 27. Okay. Okay, cool. And this is minus 6 divided by 2 is minus 3. Cool. Same answer you can get if you see, but I don't see, the factorization was 27 and 3, no? 27 and 3 is 81, and 27 minus 3 is 24, this negative and this positive. And we get x equal 27 and x equal minus 3. Cool, you see? But well, no, the problem was I don't see the combination, but I apply always the quadratic formula. You get the answer. Okay, entonces I can believe que both solution is okay? No. No, I need to verify, checking, mandatory, and the logarithmic equation, mandatory verification. And the original equation. And the original equation. Verification 27. And the original equation. Verification minus 3. Logarithm base 3 of 27 plus logarithm base 3 of 27 minus 24 should be cleaned up 4. Okay, this is the idea. I need help. How we compute logarithm base 3 of 27? Guys, either way, calculator or intuition. I need help. Come on. Participation. Logarithm base 3 of 27. You make a decision what is the way that you consider better for you. Okay, sometimes it's easy using the intuition, sometimes no. So you put in the calculator. Of course, in the calculator, you convert to a standard, no? So you put ln 27 divided by ln of 3. Because I'm using the famous chain of base formula. And you decide that you apply log or ln. Come on, put in your own calculator. Esto. Okay, another possibility, guys. You have no forgiveness. You need to know that from now. Okay, Jenny. Jenny say que es 3. Another possibility is. Gladys. Okay, cool. Cool. Okay, another possibility is logarithm base 3 of 27. I have no idea. They put x. And you convert to exponential. It's so obvious that the base is 3. The exponent is the thing I tried to looking for, equal 27. And 27, I know get 3 to the third power. See, the exponential is the same, see, the base is the same, it's because x is 3. But this is easy. but not always work. And this is safe, always work using calculator. Then you make a decision what is the way you can. Let's continue. So this guy is 3, definitely. This guy is 3. Plus something. And we have logarithm base 3 of subtraction 27 minus 24 get 3. Oh, and what about logarithm base 3 of 3? You know by memory, you apply calculator. I suppose que no. Because this is 1. This is 1. Apply the property number 2. Okay, the property number 2 say logarithm of the any base of the same number and the argument is 1. So 3 plus 1 is 4. Cool. Okay, and the answer 27 is nice. Work perfectly. 27. And what about negative 3? Negative 3 is crazy. It's obvious. And when you try to check in, you immediately you recognize it's impossible because negative number inside the logarithm to be undefined. Okay, be careful because not always happen that the negative doesn't work. That depends on the problem, no? And the problem I suppose you have another problem que the expression is logarithm base 3, suppose que es, I don't know, is 9 minus x. Entonces you replace here, entonces logarithm of 3, in another problem, no, hypothetical, minus 3, entonces positive, entonces the answer is maybe it's okay. So you plug it in, but immediately you see negative number inside the argument alone, you don't continue, you say no solution. And the only solution that we have in this problem is 27. Solution set, 27 of this logarithmic equation. Solution set, 27. Is the only value that satisfies this equation. Super clear? Okay, so we spend the rest of the time solving a lot of exponential equation, logarithmic equation I have here for you. Logarithmic equation, when you are strong, and so we are ready to apply this in the word problems. It's another challenge, but it's okay. Example 2 now. In the review package, we start today discussing any problems, any equation. When we finish, you are strong. Well, so you pay attention. Okay, 2 base 2 of the 3x minus 2 minus logarithm base 2 of x minus 5 equal 4. Okay, again 4 on the right hand side. But this is minus. But what is the first step? Always in logarithmic, I explain. Step number 1. What is that? You have several logarithms, 1, 2, 3, 4, 5. And you condense it, right? Common base, no, common base, no. Well, yeah. The base of the logarithm must be the same. So you have logarithm base 2 and logarithm base 3, suppose I erase this. You see another example today in different base, how we solve it. So we cannot apply the property number 6 because the property number 6 is possible only when the base is the same. But what should I do? You apply the property number 6 que allow me condensing this logarithm in only 1. But this is division, no? 3x minus 2 divided by x minus 5. equal 4. Do you understand this idea or no?
Yes.
After that, what should I do? Always is the same. Condensing after conversion to exponential. The arrow. Conversion this statement, logarithmic statement to exponential statement. To convert to exponential, remember the idea is clear. You ask by yourself, what is the base? What is the base? What is the base? What is the base in this case? What is the base? What is the base? What is the base? Come on.
2.
Ooh, I put the big 2. Okay, what is the exponent? I need to rate this base.
4.
4. Cool. And is equal to this expression, que es 3x minus 2 over x minus 5. And this equation, new, que by the way, 2 to the 4 power is 16, is not logarithmic equation anymore. That is a reason, okay, maybe yes or maybe no, depending on the problem, the solution of this is not 100% equivalent to the original. Therefore, mandatory verification. But this is linear, and linear is easy because give me only one solution. I suppose it's okay, but I never suppose. I apply cross multiply, and you multiply 16 times x minus 5, and 1 time 3x minus 2, it's just 3x minus 2. And you apply algebra. Distribute the property 16x minus 80, okay, 16 times 5 equal 3x minus 2. Okay, 16x minus 3x is equal minus 2 plus 80. This is 13x equals 78. Okay, 80 minus 2 divided by 13 both sides. X equals 6. Okay. As you leave like that, and the test is not credit for you. You need to verification. Need to verification. Verification where? In the original equation. Okay, never touch, waiting for this moment. You replace x for 6 and verify this statement is true. So check que logarithm base 2 of 3 times 6 minus 2 minus logarithm base 2 of 6 minus 5 should be 4. Logarithm base 2 of, this is 18, minus 2, 16, minus logarithm base 2, 6 minus 5 is 1, should be 4. What is logarithm base 2 of 16? Please help me. Remember, calculator or by hand. Intuition. Come on, you need to participate. You need to learn that part. Some people don't participate, don't do the homework. You say, no, I never understand logarithmic. Okay, it's 4. It's 4. How do you know, Jenny? Calculator or intuition?
I put in the calculator.
You put in a calculator. Nice. I respect this. I respect this. You put ln 16 divided by ln 2, no?
Yeah, the ln2 with the 16.
Now, what about the second part? Logarithm of 1, logarithm of 2 is 0. Property number 1. I know by memory. Logarithm when the argument is 1 and 0 is 4 minus 0, obviously is 4. This is okay, and this answer is perfect. I love this answer. If you want to reinforce it, this I put because the solution set is 6. An equation. Super clear or super confused? Let me know, let me know. Wow, clear. Some people left. Unbelievable. Guys, I promise that only 50% of the students pass this class. The other students are totally lost, have no interest. Okay. I respect. Don't worry, I teach again next semester. I don't know, maybe you take one of the teacher you don't like with me. Okay, I want to erase the board. Okay, and let's move on to example 3. Example 3 say logarithm base 14, oh, no standard, x plus 5 equal 1 minus logarithm base 14 of x. Solve for x. This equation. What should I do? 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 In this I am confused in this example, no? Because the professor say that the first step in the solution of the logarithm equation is condensing the logarithms. You have two logarithms condensing only one, but the problem is this logarithm is located in different side of the equation, no? That's what should I do? What should I do? What should I do? No idea. No idea. Alejandro, Angelo, Andrés. No sure. Come on, give me your idea. Yeah, I say see you are clear, no? Not sure. Angelo is not sure. Well, no participation, sure. Andre, no. Andre, are you there? Or you sleeping? No sleeping. Yes. Okay. Cool. No, you have no idea. What should I do? Not sure either. Well, so you want to condensing this, right? Using common sense, eh? Not sure either. Okay. Common sense. See the procedure say condensing, and to condensing we need in the same side. Well, okay. To say you moving to the other side. The logarithm base 14 of x plus 5 plus logarithm base 14 of x equal 1. And now to be ready to condensing this. Yes or no? Right, this is straightforward. Hello. You see what property you apply? Okay, Angelo. What property you apply now, Angelo? Andres. Alejandro. Because the only participation is the woman, no? Edward. And another name is Faisul Islam. No? Are you there, Faisul?
Yes.
Okay, cool. What should I do now?
I'm not sure.
Not sure. But it's the same that we were doing before. So when you have two logarithms, you condense it, no? Property 5, Jenny. Jenny is property 5. Property 5. Property 5. Jenny say condensing using property 5. Okay, property 5 allow us to condense it when you use plus because it's multiplication. It's logarithm base 14 of x times x plus 5 inside the argument of this logarithm equal 1. Do you understand this or no? Let me know the truth. I can explain in a different way. Do you, everyone understand? Faisal, you understand now or no? Gladys say yes.
Yeah.
Say yes. You understand now? Okay, they're saying. Okay. You have two logarithm in different side. You move it to the same side, and now you're going to use the property phi. Why property phi? Because it's plus. And the plus is multiplication. That's the only thing we are doing. Now, after that, what should I do? What should I do now? Arrow to exponential. So there are many ways to do this. However, in my opinion, the best way is, maybe it's confusing. I want to explain another way. But in this way, in this, it's confusing. Logarithm is confusing always. In this case, no, because it's 1. Entonces you convert to exponential. Statement. Entonces I asked my man, said, what is the base in this statement, logarithmic statement? What is the base? Focus your eyes in this. F14 is the base. And you copy big 14. What is the exponent? Can you write 14? Huh? 14 raised to the something. What is the exponent?
1.
1. ¿Qué es this 1? Now 1 is invisible, no? Did you write it's okay? No. No problem. However, you know, when exponent is 1, you know it's invisible. It's equal x times x plus 1. That is my new equation without logarithmic, without nothing. And we focus on the solution of this. Another possibility. Okay, some students maybe don't like, I love, but some people don't like this idea. The conversion to exponential. Well, you know the property number 2, the logarithm of base a of a is 1. They take advantage of this fact because it's 1 here. So the logarithm base 14 of x times x plus 5 parentheses is equal logarithm base 14 of 14, no? Because this one we can think que is equivalent using the property number 2. And of course, I'm using 14 because in the left-hand side, the logarithm we have is 14, the 14, 14. Entonces, es obvio, 14, logarithm is 1-to-1 function. This expression is equal to 14. And we get exactly the same of this. In my opinion, personal opinion, is easier in that way. And not always is 1. Si es, bueno, si es another number, it's more complicated. Do you understand this idea?
Yes.
Okay, so let's focus in this equation that look like quadratic equation. I want to recopy again. 14 is equal x times x plus 5. I apply this derivative property. This is x squared plus 5x. My equation is x squared plus 5x minus 14 equals 0. Boom. Nice. And for solving this quadratic equation, what do you propose me? Factorization or quadratic formula? Quadratic formula, okay. Andres, quadratic formula. Andres, A1, B is 5, and C is negative 14. Okay, entonces minus B plus and minus square root. Exactly, glad I say que by factorization is easy, que es 7 and 2. But okay, Andres don't see that. So let's do it in both ways. This is the beauty of the mathematics. Okay, now glad so remember my recommendation. When you have a quadratic equation, you spend 2 seconds to see if it's possible by factorization or no. In 2 seconds you don't find the key, open the door, you go to the quadratic formula que is safe. It's 7 and 2 because 7 times 2 is 14 and 7 minus 2 is 5 plus 7 and minus 2. One solution is negative 7, another solution is positive 2. Let's see if we get the same answer using quadratic formula. Okay. This is easy, pero not always is possible. Ok, entonces 5 square, que es b square. Sorry. Let me write letter first. I copy the formula. Guys, you must be systematic with the mathematics. Okay, I always are doing the same routine in my brain. I have copy the formula, now replace b is 5 minus 5 plus or minus square root 5 squared minus 4 multiplication by 1 multiplication by negative 14 divided by 2 times 1. Okay, let's focus it in the expression inside. Expression inside is 25, que is 5 squared, and the other 14 times 4, que is 56, pero plus. It's plus, right? Because double minus become positive. 56. And 56 and 25 together is 81. Oh, nice. I like that. Because the square root 81 is 9. Okay, so the expression inside the radical after the square root is 9. Then we have so far minus 5 plus or minus 9 divided by 2. That's all we did, split in 2 parts. Minus 5 plus 9 over 2. And minus 5 minus 9 divided by 2. Okay, 9 minus 5 is 4 divided by 2 is 2. Oh, look at this answer. It's exactly the same this answer. And this is negative 14 divided by 2 is negative 7. This answer is exactly the same of this answer. And that's it. I gotta go. I need to do something extra to get the credit, total credit. What should I do? What should I do? What should I do? Checking. What do you think about negative 7? Work or doesn't work? Checking. Jenny is checking, professor. No. And the original. Okay, let's do it. And the original crazy. Okay. Doesn't work. Jenny say negative 7 doesn't work. Makes sense, right? Because negative 7 plugging in here and the original, not here. You see logarithm and the argument negative number is completely out the domain. Let me check it for 2. Logarithm base 14 of 2 plus 5 should be equal, plain this statement, 1 minus logarithm base 14 of 2. Doesn't work. Who doesn't work? 2 doesn't work. Andre? 2 plus 5 is 7, no? So basically, I need to prove somehow. I don't know why. How? Que logarithm base 14 of 7 is equal 1 minus logarithm base 14 of 2. Give me some idea how you prove this, because I need to do. Put in the calculator, or let's continue with the intuition, or apply some magic property can help me to verify this statement is true or no. Help me, I need help. I am totally stuck. Oof. No idea, nobody. There are many ways. If you are frozen, you never get the answer. But I need to do something. Okay, I propose you one idea. Look, I'm moving again similar to the thing we were doing at the beginning. Logarithm of base 14 of 7 plus I move the same logarithm and the same side. Equal 1. And why not condensing? Using the property number 5. So logarithm base 14 of 7 times 2 multiplication by 14. Wow, fantastic. And apply the property number 2. Get the property number 2 say when the number in the base is the argument is 1, in this case 14. Okay, is the answer. Therefore, the solution of this equation is 2. Solution set equal to. Any question? Guy, you follow me or no? Can you do one more time? No, I have a lot of. Okay, I have a lot in this package. Okay, the lecture package. But I have some thousand in the review package. So you don't worry for practice because we have time and practice. The problem is that you don't waste the time in your study. Okay, I am here for willing for help you anytime. 24 hours, but you send me email, I reply with the solution. You don't understand, you again send me, I reply with more explanation, more clear. Remember Friday, I'm here in person in the campus. So you have no excuse. I promise that if you don't know, I put D or F. Okay, and you need to retake again the class, and you need to pay your money again. Okay, one very, very interesting and complicated. Okay, I suppose it's the last one for today. Well, no, I don't know. Suppose 1/3 logarithmic base 2 of x plus 6 is equal logarithm base 8 of 3x. Wow, it's the first and the unique problems. Okay, we have logarithm of different bases. Okay, we cannot do anything. Wow, I'm frozen. Because we cannot apply property 5, property 6, property 7. No. This is applied when the base is the same. The only property can allow me to change the base is the change of base formula, is the property 8. Let me copy one more time the property A. I want to explain in detail one more time. And we apply this to find the solution of this equation. Property number 8 says logarithm of the base A, que es arbitrary, of the number x is equal logarithm of the another base of the same number divided by logarithm of the another new name of A. A is the old base. B is the new one. And X is just a number. So there are many possibilities. One possibility is, in my opinion, is the best. You convert base 8, this 8, to 2. Because you have base 2 here. Another possibility is convert base 2 to 8. Or another possibility is convert both, like standard. Pero no. Well, no, you can. This is the beauty of the mathematics. Different way, maybe it's more complicated, maybe no. So I recommend this stay the same. I don't touch. I convert this right hand side, get logarithm base 8 to 2 using this formula. Compare, please. This 8 is this 8 is the old base. Now in the formula we have fraction And we have logarithm base 2 because the base nuke I need to work nice with the same base of the left hand side. All the expression is the same, in this case 3x. And the formula write x alone. But actually my problem is 3x, no x only. Divided by logarithm base 2 of a. Do you understand the application for the formula? Yes or no?
Yes.
Aha. Okay, now the problem is I need help to compute that part. Logarithm base 2 of 8. Please help me. I need to compute that part. What is the answer? Logarithm base 2 of 8. S3. Gladys say S3. Gladys, you compute with the calculator or intuition?
Intuition.
Intuition. Okay. Could you explain me what is your intuition?
So the base is 2.
Uh-huh.
Answer is an exponent. So I just thought like what exponent would make 2 to the exponent equal 8, which is 3.
Uh-huh. Excellent. Another possibility, guy, calculator. Okay. No excuse so far. Intuition in the easy scenario and calculator in the complicated scenario. Okay, you in the calculator you put a standard ln of 8 divided by ln of 2. For sure you get the same answer. Okay, so this is 3. So I copy 1/3. Logarithm base 2 non-standard x plus 6 is equal logarithm base 2 of 3x divided by 3. Because this answer was 3. No? Oh, look at that. Look at that. This 3 and this 3 cancel out, or you multiply the entire equation by 3. And when you multiply 1/3 times 3 is 1, so basically we have logarithm base 2 of x plus 6 should be equal logarithm base 2 of 3x. You see how you cancel this and this? You see or no? You see or no?
Yes.
Okay. Now ready, to be ready. If we have two logarithms and the logarithms have the same base, the conclusion is the argument is x plus 6 should be equal to 6. And the logarithm is cancelled, it's gone, no logarithm anymore, and we focus on this elementary kindergarten example, a linear equation. 3x minus x is 2x divided by 2, x equal 3. Boom. I'm leaving. I don't do anymore.
Check.
Check it, mandatory check it in the logarithmic equation, mandatory. So I substitution in the original equation 3. I need to verify that 1/3 logarithm base 2 of 3 plus 6 should be equal logarithm base 8 of 3 times 3. Well. Logarithm of 3 plus 6 is 9. So 1/3 logarithm base 2 of 9 is equal logarithm base 8 of 9 again. To see that R is equal to each other or no, we are doing similar situation. For example, this stays the same, but I apply one more time the chain of base formula, que es logaritmo base 2, so I convert 8 to 2, of 9 divided by logaritmo base 2 of 8, que we computed before, que es 3. Look at that. So 1/3 logarithm base 2 of 9 is equal logarithm base 2 of 9 over 3. No, it's the same, no? The multiplication by 1/3 and divided by 3 is the same. It's okay. The solution 3 is perfect. Uy, no, don't erase. It's perfect, like that, x equal 3. Solution set for this equation is x equal 3. The next Wednesday, we continue doing, the answer is 3. More exponential equation, a logarithmic equation, sorry. And we start the applications. Okay, the application is very complicated, but I want to explain clear and slow down. So now, we have time to do our best to explain everything, because most important is the application. No? We study mathematics, we study algebra to apply in the real life. In real life is the, you see application of the finance and the money, or application of the nature and the biology, or in the, for example, study how propagate disease, the coronavirus, okay, using logarithmic function. Okay, guys, so now I suppose that you are study doing the homework online. We have 3 homework, no? Okay, and that's it. I have another class right now. So now I want to wish have a nice day. Bye-bye.
Bye, Professor.